Hey everybody, welcome back. Glad you survived Chapter 7. I know for some of you the calculations part of Chapter 7 was a struggle. Most of you did really well on the first part of the test for Chapter 7, the acid and base and pH type questions. But I know a lot of you struggled with some of those problems. But the good news is we're done. You can put your calculators away for the rest of the semester unless you're still working on some things from earlier. We're basically done with any kind of math in this course. We are down to our last officially 3 weeks till summer, 15 classes, 15 days. But I have 2 chapters left, and I imagine I should be done by the end of next week. So that final week we may just see where we're at and see if anyone needs some things to be done. If you're trying to update your mark, we may be able to find some ways to do that in the final week. But for the most part, I think we should be done by the end of next Friday. So I encourage you, if you haven't got all of your things done that need to be done, you could hypothetically leave them until after we're done this unit on electrochemistry. And then when we come back, when we're done, you can actually come back and try to finish up anything that's not done yet. Okay, so just a thought, or else try and get it done, and then maybe you'll be done everything by the, I think it's the 18th, 7th, 8th, 12th, 19th. So this last unit is the last 2 chapters. They're both very, very short. I think there's only 3 notes for each chapter, and there are no STSEs left. There are no career assignments left. I think there might be a mini activity or 2, but they're quite short. And we'll see. We've done so much, I might actually, well, we'll see. I may just do the 1 mini activity for electrochemistry for Chapter 9, and then that will be the end of everything, except for our last test on electrochem. Right, so we're very close to the end. So stick with it. And like I said, try and not lose the faith. Just keep going. Try and get everything finished that needs to be done. Stay on top of the hub. I'm going to leave a similar message in the hub, but you may want to just double check and make sure that you're ready for what's coming up. Okay, so Unit 5 is electrochemistry. So I'm seeing 2 things there. I'm seeing electro, which means electricity, which is based on electrons, and chemistry, which is looking at the elements on the periodic table and atoms. All right, so as we talk about this whole unit on electricity and chemistry, or electrochemistry, it all comes back basically to electrons. So when we're thinking about electrons, we know that certain elements have the ability to gain electrons, while some have the capacity to lose electrons. Now, in this first part of Chapter 9, we're going to be looking largely at single displacement reactions, because single displacement reactions are, I think all, oxidation reduction type reactions. So, oxidation and reduction. We're going to talk about these 2 words over the course of today's note. Again, today's note should be a fairly short note, and then, like I said, we're so close to the end. Okay, so as we look at what happens here when atoms gain or lose electrons, so I'm really looking specifically at what we've looked at in ionic bonds and in the formation of stable outer shells. Now, if I look at a single displacement reaction, like this one here is a single displacement reaction that's reacting zinc plus copper 2 chloride to make zinc chloride plus copper. Okay, so notice what's missing from the equation here are the chlorides. I have zinc metal reacting with aqueous copper 2 plus ions. Now they're aqueous 2 plus because they were part of copper chloride, and the copper chloride, again, remember the 2 down here would have been up from the copper 2, and the 1 beside the copper would have been the chloride minus 1. Right? We know that chloride is minus 1. So they're copper 2 ions, and the same thing on this side over here. I'm creating copper ions, copper atoms, copper solid, elemental copper, like copper pipe or copper wire, and I'm creating dissolved or aqueous zinc chloride ions. Zinc is a +2, chloride is a -1, so I end up with zinc chloride there. Now notice what has to happen here. The zinc over here is going to turn into this zinc. Right? Now how did that happen? Well, in order for a zinc atom to become a zinc 2+ ion, it has to lose electrons. Right? So my zinc atom, my zinc atom is going to become a zinc 2+ ion, right? Because it loses 2 electrons. If I lose 2 negatives, I become +2. And the copper up here, which was a copper 2+ ion, is going to turn into an atom of copper. How does an ion of copper that's +2 become neutral? It must gain 2 electrons. So the copper 2+ is going to turn into a copper atom by getting rid of the positive charge, and I do that by gaining electrons. So notice 2 things have happened here. The zinc has lost electrons and the copper has gained electrons. Now I'm going to bring you to the cheesy part of chapter 9. The cheesy part is this little saying here that I learned when I was in grade 11. It's in this textbook, it's in my 4U textbook, it's in the 3U textbook, it's in every chemistry book that was ever written, and it is an acronym that says Leo, who's a lion, Leo the lion says grr, right? Because Leos say grr, they growl. Now, what that little acronym is reminding me is that if an atom, whatever the atom is, if it loses electrons, we say that it has been oxidized. Right? So over here, the zinc loses 2 electrons to become zinc 2+. That's right. So it lost 2 electrons. So the zinc atom was oxidized. And it says, when an atom or ion, it should say, gains 2 electrons, it is reduced, right? So the copper ion up here, which is copper 2+, is going to gain the 2 electrons from zinc to become copper, right? So we say that the copper 2+, this one over here, is going to be reduced. This one is oxidized, it's losing electrons. This one is being reduced, it is gaining electrons. Whoops. Now, if you kind of bear with this, it will make a lot of sense. So those 2 words are the 2 main terms in all of chapters 9 and 10. This chapter is actually called Oxidation and Reduction Reactions. Now notice there's an important piece here. In order for zinc to be oxidized to lose electrons, in order for zinc to be oxidized, I need something to be reduced. Something has to accept those electrons or gain the electrons. So zinc is going to Leo, it's going to lose electrons and be oxidized. The copper is going to gain those electrons and it's going to be reduced. It's going to be grr. So the zinc is Leo and the copper 2+ ions are grr. Notice that it's impossible to have a Leo without a grr. The 2 reactions must happen together, right? So I can't have an oxidation with an oxidation reaction without a reduction reaction. So the 2 reactions have to happen at the same time, and the whole process is called a redox reaction. Reduction oxidation reaction. So the reaction that I had that I was showing you up here, this reaction here, zinc plus copper chloride becoming zinc chloride and copper. You say, well, that's a single displacement reaction. It is a single displacement reaction, but it's also a redox reaction because the zinc is going to be Leo, it's going to lose electrons to the copper ions, and the copper ions are going to be grr. The copper ions are going to gain electrons and be reduced. All right, so as silly as that sounds about all the Leo and grr, just be remembering that everything in this chapter involves Leo or Gur. So I'm going to say that Leo and Gur at least 100 times in the next 5 or 6 notes. Now, to make life a little bit easier for ourselves, we often break that chemical reaction that was up here, right, this one up here. We're going to get rid of the chlorides because the chlorides don't do anything. Right? The chlorides are spectators, right? Remember spectators. I have 2 chloride negative ions here, and I have 2 chloride negative ions here. So they're not doing anything. They're spectators, and I'm going to ignore them in this net ionic equation. Okay, so let's go down to our half reactions. So I'm going to break that reaction, the zinc being oxidized and the copper being reduced, into 2 halves. 2 half reactions. Okay, one of the half reactions is the reduction, and one of the half reactions is the oxidation. Now, it turns out that the copper ions are what are being reduced, and the zinc atom is what's being oxidized. So if I try and write this in terms of just a single process, where the copper 2 plus is going to turn into a copper. How did I do that? By Gur, by gaining 2 electrons and by being reduced. How does the zinc become a zinc 2 plus? It becomes a zinc 2 plus by losing 2 electrons. So when it turns into zinc 2 plus, means there are 2 electrons that get kicked out. All right? So there's the second part of this, the second half of the reaction, or the second half reaction. That is the oxidation reaction, where the zinc is Leo, it's losing electrons and being oxidized. Okay, so when I take my 2 half reactions from up there now and add them together, my first one was copper 2 plus 2 electrons making copper. Copper 2 plus 2 electrons makes copper. My oxidation is zinc makes zinc ions plus 2 electrons. Zinc makes zinc 2 plus ions plus 2 electrons. Notice that I've got 2 electrons on both sides, so they can cancel out, and I'm left with copper 2 plus zinc makes copper plus zinc 2 plus when I add them together. So the 2 half reactions together make up my whole reaction, my overall reaction. Right, so there's my reduction reaction, there's my oxidation reaction. Notice I'm going to cancel the electrons on left and right, and I'll end up with, because whatever I produced in this reaction was used in this reaction. Okay, I produced it and then I used it. So really there's no electrons left over or extras that are needed to make this work. So if I look at, oh my goodness. If I look at the sample here, lead reacting with copper 2 nitrate to make lead 2 nitrate and copper. Do I have room to do some work here? Oh, I do. Okay, so I'm going to work down here. So if I've got my lead, let's make this a bit bigger, reacting with copper 2 nitrate to make copper plus lead 2 nitrate. Okay, notice that the nitrates, I've got 2 nitrates on this side and 2 nitrates on this side, so they're going to cancel each other out. So I'm really left with lead plus copper 2 plus on the left, and copper plus lead 2 plus on the right. Okay, and now I'm going to separate them into my 2 half reactions. The first one says the lead is going to turn into a lead 2 plus, and the second one says a copper 2 plus is going to turn into a copper. Right? Lead is going to turn into lead 2 plus, and copper 2 plus is going to turn into copper. So now let's look at the 2 half reactions. How does the lead become lead 2 plus? It must be losing 2 electrons. Now, an easy way to do this is to make sure that the charge on both sides is the same. So I have to add negatives or electrons to the side that makes them balance out. So for the lead one, I've got 0 charge on this side and 2 pluses on this side. That tells me I need 2 minuses on this side. Those are my 2 electrons. If I look at my copper, I've got 2 pluses on this side and no charge on this side. To get rid of the positives, I'm going to add 2 negatives to this side. Right. So what I can see is the copper 2 plus is being added to 2 electrons. It's gaining 2 electrons. So there's my GR. There's my reduction reaction. And the lead is turning into lead plus 2 free electrons. It's losing electrons. So there's my Leo reaction. Okay, so that's how we're going to do our oxidation and reduction reactions. Okay, let's go back up here. The second one says magnesium is reacting with oxygen to make 2 MgOs. Magnesium reacting with oxygen to make 2 MgOs. So let's get rid of all this stuff in here. Again, remember you can always move your video back if you need to go back. I just want to use that same working space here. Let's switch to my other pen here. Okay, so the other one says I've got two magnesiums reacting with an oxygen gas to make 2 MgOs. So notice what's going to happen now is I'm going to take the 2 magnesiums on this side and they're going to turn into 2 magnesiums in a compound on the right. Now this is a bit tricky, this one, because MgO would suggest that the O would be 1 and the Mg would be 1, so they would come up. But it turns out, if you check your periodic table, oxygen's always -2 and magnesium is always +2. So it would really become Mg2O2, and then we would cancel the 2's out because it's an ionic compound, metal, non-metal. So magnesium are 2 plus ions, and the oxygen on the left is going to turn into 2 oxide ions, 2 oxygen, 2 minus ions on the right. Now notice on the first reaction up here, oh, I've got to get rid of that too. Let's get rid of this. The first reaction up here, which is the magnesium, I've got no charge on this side, and I've got 2 pluses, right? So I've got 4 pluses on the right. So to get rid of the 4 pluses, I need to add 4 minuses. Right? And then on the bottom reaction, oxygen turning into oxide ions, I've got 2 minuses on the bottom here. So I've got 4 minuses on the right and no charge on the left. So how do I fix this? I guess I have to add some minuses to this side. How many 4 minuses, 4 electrons, are going to be added to the right? So notice that ultimately I'm going to produce 4 electrons, but I'm also going to use those 4 electrons. So if I say which one is GR, I always like to look at the GR first because it's easy to see which one's gaining. Oxygen's definitely gaining 4 electrons. So oxygen is being reduced, and my magnesium is losing those electrons, and it is Leo. Okay, so there's a couple of reactions that are the samples from our textbook. Now, in our textbook, there is a mini activity. I think this is the one last assignment of the year, I believe, on page 328. So I think I'll create a drop box for this, and I'm going to use this as a lab mark because it's really short. It's not much to it, and really straightforward. And it's really good practice at doing Leo and Gur, doing oxidation and reduction. Remember, these are redox reactions. A reaction must have, if it has reduction, it has to have oxidation. If something is losing electrons, something has to be gaining those electrons. All right, so redox reactions. Now there are some pause and check questions on page 328. And let's get rid of all this. And there are 2 more questions down here that you can work on: copper turning into silver nitrate and sodium reacting with bromine, liquid bromine. Okay, so I'm going to stop there. Like I said, there's the first of our 3 notes for Chapter 9. And then we will come back to this. We'll do the next note tomorrow night. I will create a Dropbox for that little mini assignment. Again, remember, this is a short, fast one. There's only 3 quick questions. I bet you can do the whole mini activity in 10 minutes or less. All right, so it just says write the half reactions for the reaction, and then what is being oxidized, what is being reduced. Okay, so it's really quite straightforward. We'll come back to this thing called oxidation numbers tomorrow. All right, so again, I hope you're doing really well. I hope that you are still got enough energy to kind of kick through these last 2 weeks. As I said earlier, I think you'll find these last 2 weeks are really straightforward, and you're not going to have too much trouble getting